we can see your screen right now. Yeah.
Can you see the slide?
Yes, we can see it. Yeah, we can see your whole desktop with the slides. Yeah.
Okay, very good. Hi, so my name is Daniel Correa. I had actually made a slide to introduce myself, but I ended up deleting it. But I'll tell you guys a brief introduction anyways. I'm in the master's program for data science. My previous experience is in marine science. I have a degree in marine biology, and my interest in data science is the applications of data science and technologies in marine science. In particular, I have interest in robotics, autonomous systems, sensors. I have previous experience with sonar and doing things in marine science. So, the information technology and networking and stuff, other aspects is not really, I dabble in it, but it's not really my explicit interest. So anyways, so I'm going to be doing the presentation on this Bastion system, network and networking, container networking. So this is a new subject for me, so just bear that in mind. And if perhaps if I give some bad information, Pin Chao, you can make note of that. So anyways, so I'm going to go a little bit more in depth into the microservice basics. And
Daniel,
then,
could you enlarge your screen for the presentation?
oh.
Okay, thanks.
Is that good? Okay. So I'm going to go over the microservice basics again. And then we will talk about Bastion. And finally, just a short discussion on why it's important for us. So can I get maybe a quick sample of, is there anybody here who is not familiar with containers, Docker containers, microservices? Because this isn't something that I've gotten previous education on. Okay, so maybe I'll take it that everybody is. All right, so then bear with me. So what are microservices? Microservices, the way I would describe it is an evolutionary path from monolithic kind of programming to this microservices. So it's kind of analogous to you have single cellular organisms that evolve into multicellular organisms. And what is the purpose of microservices? Well, they really just do the same thing, which is run a program. But they do it in a different way and with some benefits, or I should say some trade-offs. Are you guys still there?
Yes.
Yes, Daniel, we can hear you. Yeah.
All right, my Zoom is acting up, so I'm just gonna continue. So microservices are increasingly being used in industry to accomplish their tasks. You could visit this article to see how microservices are used for an Amazon, Netflix, Uber, for example. This is an example of Uber's microservice system, and you can see how microservices are basically a decompartmentalization of many aspects of a program broken up into several smaller pieces. And those pieces are integrated together in a network rather than being a single program that that just does every action by itself. So what are microservices made of? The basic unit of microservices and of these individual components is a container. And the container has all of the program code and other things into a small package, which essentially just does some action. It does something productive for the whole scope of the program. Sometimes containers are compared with virtual machines. I guess they say they have some aspects to it. For example, like Docker containers are, I guess that they're similar in a way that when you're using when you compile a Docker container on your system, whether it be Windows or Mac, for instance, that Docker container will have elements inside of it based on that are from Linux kernels and for the networking purposes. So, but really, they're a very simplified version of anything related to the operating system because they essentially run on the host operating system through the Docker engine. So container networks are run on platforms like Kubernetes. And what these do is they organize all the different containers into that network, like I described previously. And they all run and they all do their functions in order to accomplish a task. So for example, with Uber, you know, these different operations will be running to keep track of your account and keep track of your driver and keep track of getting you to your destination. So so the main thing to take away from this is that the container networks are they're heavily dependent on a network infrastructure to get all of this done. So how do they do that? So in these pictures, you can see here, there's various different layers of a network, of a container network. And they're all based on Linux networking tool sets. So you have containers have networks that link different containers together to transfer information. Containers are also grouped into nodes or pods, and those different pods have network interfaces amongst each other. And the whole system also interfaces with the host server or the host computer that it's running on. And those systems interface with a user somewhere else on the internet in the world. So many different layers of networks. But essentially something at some point, a packet of some kind ends up going to a container so that it can do something. And I guess you can get an idea of what that might look like in that GIF. And these network interfaces are a hodgepodge of physical network interfaces, virtual ones. So when I think about microservices, I consider them to be fractal kind of nature. So when you access a service, depending on what it is, you never know how many of these things are spawned, how many things, how wide does it branch out to accomplish these kinds of tasks. So it's definitely a very interesting subject and application of fractal theory. So in summary, microservices do all of these things that we want, like the services that Amazon provides. They're based on these container technologies and container networks. Many of these things are open source, and they depend on a very complex network infrastructure. So due to these things, naturally, there's been a lot of security implications. Security or network complexity and security was it, well, network complexity is a trade-off for using microservice style programming. And I guess network security, it doesn't have to be a trade-off, but it was when everything got started. But now network security is definitely a hot microservice. Network security is definitely a hot topic for of study. So yes. So now we're going to talk about Bastion. So the Bastion research and program, they identify 5 particular vulnerabilities that are common in the container network to container network platforms. In particular, Docker and Kubernetes and a few others of the popular ones. And using this Bastion program, they mitigate these network vulnerabilities and improve performance on par with other similar microservice security products out there. So this is some snippets from the paper in which they describe what the particular issue, where the issues are, and now the vulnerabilities associated with each of those issues. You have 5 in total. And in this bottom graph here, they explain what are the particular threats and how these threats, how these different platforms can handle these different threats. So the initial Docker system is pretty much vulnerable to everything that they describe. So, and you can see why security was an issue for that. So the Bastion program itself has 3 main features. There's a manager, the network visibility service, and the traffic visibility service. And the Bastion system works alongside the container network platform. So there's, as far as I can tell, there was no real modification of a container network platform. It's kind of goes on top of that and works on top of everything. And it also benefits from newer technologies like BPF and XDP, which I'll talk a little bit about later on. So this is a description snippet from the paper of where the Bastion system is working and sort of what it's doing. So keeping in mind that with the complexity of the container network, there not only are there different kinds of interfaces, there's also sometimes even hidden network services that you can't really access from that happen between containers. So Bastion implements different parts of its program at many different levels of a container network. So from the host side, which is the highest point, all the way into the container and intercontainer connections, Bastion is being deployed to get a better handle on the container network. You can see in the picture here where they say that Bastion will, so Bastion is kind of like a proxy server in a way, where it tries to gain control of particular particular parts of the network and control the transfer of the information between those. And the main goals of the Bastion is to simplify the network, isolate as much of the network as it can from each other, where connections aren't necessary, to constrict access to the network of all the different parts or all the different containers. And this improves the security and reduces vulnerability of a lot of those attacks that can corrupt a container network. So I had mentioned that Bastion utilizes the BPF XTP, which is a relatively new alternative to the IP tables that they use in networking, Linux networking. And I can't really go into detail about BPF or XTP, but I can say that that people are from what I've learned, that it is being considered as the next generation, or the alternative to the traditional networking that everything has been built upon. And the BPF and XTP itself lends to the performance increase of a program like Bastion. It's also used in the Cilium, which is where I learned more about this by studying the Cilium program. And it had the BPF XTP has particular aspects to it that improve security and also are improving performance too. So in summary, the Bastion system is reinforcing critical components in the container network that are known to be vulnerable to security-wise. It's using, they're implementing newer technologies, improving on the traditional IP tables and stuff like that. And they are basically using a common sense approaches to improving the network security, which is, like I said, like similar to proxy servers. So, you know, they identify every particular network pathway, you know, put a gatekeeper on that in a sense, and track things and isolate parts of the network, and remove parts of it that are not necessary for a particular function. And so that everything can operate without too much stuff being exposed to a potential attack. So why is this important to us? Well, microservices are becoming the industry standard for applications. They are really, but you can say in some places they're still becoming that. Perhaps if you learn more about this stuff or become expert, you can get a job doing microservices, or maybe migrating older systems into microservice platforms. That might be a good path. And security itself is just a important topic for data centered services. So everybody wants their data to be safe and secure and not